webinar co-organized by 3 partners: Current Europe, enabling network technologies throughout Europe, Renewables Grid Initiative, and also Green Deal Ukraine. I'm Susanne Nies, the project lead of Green Deal Ukraine, Helmholtz Center, Berlin, based here in Berlin. So we have conceived today's webinar, Innovative Grid Technologies for Sustainable Energy Security in Ukraine and Beyond. We will look today into the use case of Ukraine, but also beyond. Ukraine can be seen and is largely seen as a laboratory for innovative solutions. The likes of Swissgrid are looking, or the Baltic TSOs are looking into how Ukraine manages cyber crisis, security issues, and therefore deploying innovative grid technologies is not a luxury, but a must to ensure sustainable energy security. Let me briefly introduce our speakers for today. We have very happy to see you, Yolanda Garcia Mezquita from DG NR. Yolanda is also overseeing the work of energy community, the interaction between DG Energy and energy community. We have Andrzej Ceglarz from Renewables Grid Initiative. Also, he has been working on grids in Eastern Europe in his past at Frankfurt Oder University. Layla Sawyer, who worked for Smarten before, and who is now the Secretary General of Current, an ever-growing association of innovative grid technology companies. Houghtaling from LineVision, Romain Coullette from Epsilon Composite, Brian Barry from Ampacimon, and Mark Norton, former colleague and friend from N3 Times from Smart Wires. Fantastic pack of speakers for today. I see that more than 48 people are now in our webinar, and you should also participate very actively. So please note your questions in the chat, ask your questions when you have seen the presentations. So what will we have on today's menu? We will first of all have Yolanda giving us an update on the role of the European Commission in assisting the Ukrainian energy transition. I hear some background noise somewhere. Okay. Ukraine's energy transition. We all know that Ukraine is a candidate country. The recent enlargement report is just published. So it's very interesting to understand what is now the Commission's role to support Ukraine to find its place in the EU, hopefully in 2030. Andrzej is going to give us an overview on the role of an optimized system planning in supporting energy security. We all know that RGI is the association combining NGOs that are keen on seeing impact on nature, on climate diminished, and also network operators across Europe. Layla will give us an update on the role of innovative grid technologies in increasing energy efficiency, but also energy security. I will present a study that I did recently with a Ukrainian colleague and collaborator of my project on what options we have to boost the power grids to support Ukraine in these dramatic next 2 winters. I was just there 2 weeks ago in Ukraine and have to say the situation is unprecedented in terms of challenges for a country with such a huge network. Alex and Brian and Mark will then come in with their solutions. What is the contribution of dynamic line rating, of FACTS devices? What can be done? How fast can it be done? And then we have the Q&A session with you. So please, Yolanda, you have the word for your contribution on the role of the EC, possibly also now with the new commission coming in, Ursula von der Leyen's new commission, end of this year or early next year. Thanks a lot.
Thank you very much, Susanne, and thank you for the organizers for this pertinent and very important event. So it's a pleasure to be here and to try to give a big picture before colleagues go into the technical details of the grid. So really looking forward the technicalities in the grids. So I want to start with the broad picture and the importance of the grids, and with a clear statement: there is no transition without transmission. So I think you are putting the focus on grids, and this is very much welcome. I mean, we know all the benefits of the grids in terms of security of supply. To enhance interconnectivity brings security of supply to the countries, is saving cost, so it's helping to competitiveness and affordability of our energy systems and economies, and it provides greater flexibility, and we move towards more renewable integration into the system. So we need to be more flexible from both the demand and the supply side. So we need to make through grids to enable this connection between supply and demand. So this is clear, is the role of grids is without any doubt at the center of our transition towards the green transition. Grids is a priority in the EU Commission. You have already, Susanne, mentioned. Our President Ursula von der Leyen, in the political guidance in front of the Parliament in July this year, already explained the importance of competitiveness and already indicate the crucial role of grids in terms of enabling of the transition. So this has been as well reflected in the mission letter of our Commissioner Designate for Energy and Housing, Dan Jorgensen, where he has in front of him quite a lot of challenges and roadmaps to prepare action plans, including electrification. Without grids, it's not possible, the electrification, cleaning energy investments, but in particular, it will be a focus on grids. So I think this is an important event because we are going to really start making clear the importance of grids coming from the EU energy policy priorities. I want to highlight as well Mario Draghi report, because in the report of Mario Draghi, he as well reaffirms the importance of the grids and interconnectors, and he highlights the need to have a common action in this direction and founding at EU level as well. The Commission started putting the focus on the grids exactly 1 year ago, when we launched the Grid Action Plan, adopted November 2023, where we already highlighted the role of the grids and the regional cooperation, because this is going to increase or decrease the generation cost, and this is important in terms now 9 billion annually to 2040. So I think this is an important element, but as well has been highlighted that we need much more investments in grids and a storage capacity, around 6 billion euro annually. So this is a fact. The regulatory framework is really extremely important, and I want to highlight the Trans-European Network, and in particular the projects of common interest and projects of mutual interest where Ukraine can as well participate. We are now preparing the second list of the projects of common interest and mutual interest, and in particular we pay attention to the CESEC region, where CESEC, Center and South Interconnectivity region in Europe, what it includes 8 member states, but it includes, importantly, 8 contracting parties of the energy community. So the 6 Western Balkans, Ukraine, and Moldova. So we need to have the full picture. Now, in the energy community, we are preparing the first list of projects of energy community interest, what we call PESI list. This list is going to be adopted in the Ministerial Council of the Energy Community, 12th of December in Vienna, and I can anticipate that Commission has already identified 6 projects, and 5 are interconnectivity projects in the region, and 1 is a storage project precisely in Ukraine. DTEC is an electricity project in DTEC, 225 megawatts. So this is just to highlight the importance of the region. As well, there are 2 lines, interconnection lines between Ukraine and Romania and between Ukraine and Slovakia, that they are now included in a 10-year network development plan. So this is going to help to increase the interconnectivity of the region, and in particular to increase the interconnectivity of Ukraine. Talking about the regulatory framework, this is essential. And here we are already working with Ukraine. We have created what we call a EU-Ukraine high-level working group, where we are working on energy reforms in order to facilitate the acceleration of the integration of the Ukraine in the electricity markets. This is completely in line with the EU accession talks for enlargement that started really formally in June this year, and now we are preparing what is called Chapter 15 on energy for enlargement, and Chapter 21 on transmissions network. So this is a framework completely aligned or try to push Ukraine towards the reforms needed in line to be part of the European Union as a member, the sooner the possible. I want to highlight, before to conclude, the enlargement report has been recently released by the European Commission, 30th of October, and in the enlargement report, it recognized Ukraine, the advance that Ukraine has done in the energy sector, with 3 key recommendations for Ukraine. One is to implement the national energy and climate plans, where interconnectivity is an important element. Second, establish a market-based framework for renewable energy investments. We need to stimulate investments in renewable system, but also in order to connect the new renewable generation into the system. The grids are essential for this. And third, the adoption. Ukraine needs to adopt the electricity integration package. This is essential. In order to be part of the European Union, it's important to enabling to implement the electricity integration package. Here, I want to really be more precise in terms, Ukraine needs to transpose the electricity integration package. It needs to take action for the regional transmission system cooperation. It needs as well to operationalize the capacity calculation regions, and last but not least, enabling the single day ahead and intraday market coupling with the European Union. This is only possible if you have the grids already. So I want to finalize as well to highlight all the steps that Ukraine is doing, in particular in adopt REMIT, which is extremely important as well in order to bring transparency in the wholesale market and reduce the market manipulation. So this is important as well. With Ukraine is making progress towards the implementation of the joint capacity allocation with interconnectors with Hungary, with Slovakia, with Poland, which is now conducted via the joint allocation office. So this is an important step forward in something very concrete that Ukraine is doing. Together with Ukraine join the mechanism for inter-transmission system operator compensation, which, as you know, is crucial as well to be part of the European Union. I want to give only one word about the EU stand supporting Ukraine since the invasion of Ukraine by Russia in February 2022. We have three-point plan with repair. We are helping Ukraine to repair the infrastructure has been damaged in the energy sector, in particular for the preparation for the winter. We connect Ukraine with EU, with the Continental Europe, Ukraine and Moldova. And third, we are increasing the investments in order to decentralize the generation in Ukraine, in particular through PV solar panels. So I want only to highlight this connection between Ukraine and the Continental Europe, because thanks to this, and thanks in particular the decision taken by the transmission system operators, European transmission system operators, 29th of October, now the increasing of the capacity, interconnector capacity between Ukraine, Moldova, and the Continental Europe has increased 25%. Is in total 2.1 gigawatt from December this year until spring, plus 215 megawatts, which is always in emergency, is available for Ukraine. So this is an important capacity, electricity capacity, that is helping Ukraine, in particular immediately after the attacks, to stabilize the system and to ensure that the electricity is flowing from Europe, from the neighboring countries, to Ukraine. So I think what we want is to keep this 2.1 as permanent capacity after a spring. So we are working, and this requires reinforcement of the grids internally in Ukraine, but also with the neighboring countries. So I want really to stop here, but of course to show again our commitment as European Union with Ukraine in all aspects, in the financial aspects, in the enlargement in terms of regulatory reforms, but of course in the interconnectivity and support, in particular those elements that they are needed in order to enabling the green transition of Ukraine and the security of supply of the system, and one of them is of course grids. Thank you very much for your attention.
Thanks so much, Yolanda, for this overview. Just one point, I think you meant it. You mentioned several times transmission, but I believe you mean grids and you mean also distribution, which exactly, sometimes transmission summarizes both, but I clearly believe that we need to think about both types of networks. People like Leonardo Meos from FSR have recently suggested to merge NSOE and EUDSO, which I believe personally is a great idea if you take the gas out, but that's another discussion. Just like we need to have those two in mind. And I think also we can really congratulate the European Commission, also the energy community, for giving so much direction for Ukraine, because very obvious that this country, when hopefully the war ends and ceasefire comes, can never exist again in a vacuum between EU and very aggressive Russia, and therefore needs to fulfill all these reforms to join the EU as fast as possible. And the same applies, of course, to Moldova as well. So thanks so much for this comprehensive overview and all these actions taken. Just asking, is there anyone who has an immediate question from the audience to Yolanda on her contribution? Just raise your hand. I don't see that. So let's then please continue. I now hand over to Andrzej Ceglarz. And Andrzej has his PhD from Technical University of Munich. He's now the director of energy systems at RGI. As I already mentioned, is this unique platform, RGI, collaborating between the NGOs and between the transmission and distribution system operators across Europe. Andrzej, you have the floor.
Thank you very much, Susanne, and thank you very much also for the joint efforts to organize this event, because I think it's very relevant in current times, but also bringing different actors and different perspectives into the discussion to work jointly on some common solutions. And can we go to the next slide, please? And just a very short overview. So Susanne mentioned already that Renewables Grid Initiative, RGI, is an association of some of the European transmission system operators, as well as climate and environmental NGOs. And while today we're talking about innovative grid technologies, such unusual collaborations are also very innovative. They can bring new ideas, new inputs to work jointly on solutions that are needed to progress with the energy transition, as well as with increasing the energy security. And today I'm going to talk how the optimization within system planning is important to increase the energy security. And next slide, please. And while already within the last 2 years, they have been very clear examples of collaboration and cooperation between the European Union and Ukraine, and in that case Moldova. And here you can see just a snapshot of the news from more than 2 years about synchronization of the electricity systems of these countries with the European one. Let's say more milestones are included in the paper that Susanne published with colleagues, but it shows that collaboration and these approaches to work together are possible and are needed, especially in times of the crisis. And how does it relate with the system planning? So the European grid planning process, the 10 years network development plan, also about which Yolanda mentioned in her intervention, already among its key messages mentions about it mentions about the importance of collaboration to achieve sustainable future, but also about the role of the innovation in optimized planning. But innovative technologies will be discussed by the colleagues. How does it relate to increasing security? Here you can see some main messages, or let's say main points related to the planning, which actually are intertwined and interconnecting. So while reducing, what about reducing dependencies and enhancing resilience? So the optimization reflected in energy system planning can help in prioritizing domestic energy sources and the centralized energy system, what allows to strengthen resilience strategies, ensure critical services, and maintain power disruption. So this is something what actually Ukraine has been struggling with in last years, and a good and optimized system planning can help with that. With optimization, and this is something that is already included in the TYNDP scenario building process, allows to emphasize the integration of renewable energy sources. And this can help aligning with the goals of diversifying energy mix, reducing energy supply shocks, at the same time supporting environmental goals and reducing greenhouse gases emissions. And this can also help to leverage flexibility and exploring full potential of different flexibility solutions, what can help in maintaining the system stability and reliability. Intensified regional collaboration. It was very good to hear already the points of Yolanda, that some of the projects that aim at connecting and integrating Ukraine system into the European has been granted with the status of projects of common interest, because that's also the role of the process leading to identification and selection of those projects that can be granted with the EU funding. But what is also important, they can be granted with technical assistance for the implementation, what can enhance energy security. This can also help in advancing forecasting, anticipating and mitigating different risks, and strengthen ties with neighboring countries and neighboring energy systems, allows for the integration into the European electricity system and benefit from all aspects of collaboration. And this leads to to the last point about investments. And again, great to hear the points that Yolanda mentioned about related to repairing Ukraine and infrastructure and bringing additional funding for it. So also to make sure what kind of assets or what kind of projects to prioritize. Optimization within energy system planning will help for doing that. It will allow to reduce waste, some losses, increase efficiency, at the same time make the best use of available resources and increasing security. But for those investments, what is also needed are the, let's say, innovative grid technologies. And I think that I will finish here and also give the floor to other colleagues who will discuss them. So thank you very much for this.
Thanks a lot, Andrzej. And if RGI wouldn't exist, it needed to be invented. I think it would be great to engage also with candidate countries as RGI and get them on board, maybe give them a free seat or invent something innovative there to deliver on against the stakeholder participation objective that forms also part of the general EU integration strategy. Now I hand over to Layla Sawyer. Layla Sawyer is the Secretary General of Current, the voice of innovative grid technology companies. Before she headed the business of Smarten, Smart Energy Demand Coalition. She worked on demand side flexibility, but she also worked with climate NGO in the Netherlands and has a huge experience also because she studied sustainable business and innovation in Utrecht. Layla, what is the role of innovative grid technologies for energy efficiency and security?
Thanks very much, Susanne, for that kind introduction. I hope you can see me well because surprisingly, the sun decided to come out in Brussels very unexpectedly, and that is a bit messy, the light settings. So thanks, Susanne, for this kind introduction and for partnering with Current on this extremely important topic and innovative grid technologies to increase energy efficiency and energy security in Ukraine. So going to the next slide, first, a few words about Current. We are the voice of innovative grid technologies in Europe, bringing together now more than 20 innovative companies that are working on getting more out of the existing grid and building new grids with a much higher capacity. We know that powerful electricity grids, especially in the context of Ukraine, are crucial for energy security, but that building new lines can take a long time, even when the conditions are ideal for that. We will have some extremely interesting presentations from some of the members from Current coming up. But to start, I would just like to give a high-level overview of the benefits that innovative grid technologies can bring. So if you could go to the next slide, please. Yes. So first of all, before going into how innovative grid technologies work, I think it's good to show what is it that innovative grid technologies can do. So earlier this year, we did a study together with Compass Lexicon, supported by Breakthrough Energy, looking at the benefits that innovative grid technologies can bring, and we categorized them into several superpowers. And by this, we mean firstly, increasing the capacity of an existing line, for example, through advanced conductors, which you will hear more about. Also solutions like storage as a transmission asset, in which case batteries are dedicated transmission assets, helping the grid operator meet the N-1 requirement, and in this way, using more of the existing line. We looked at superconductors as well. The second superpower here is better understanding the line limit of existing lines. We will hear much more about use cases from dynamic line rating later on. Third is dynamically controlling power in the grid. And lastly, better understanding of inertia limits. These are all technologies that can help to integrate renewables more quickly, which also is contributing to increasing energy security. If you could move to the next slide, please. Yes, thanks. So then together with Compass Lexicon, we looked at how much grid expansion will be needed by 2040 and what are the benefits that these technologies can bring. And then taking all of these superpowers together and combining them, how can they help Europe reach their decarbonization goals? And while this model that we created may not translate 100% into a model of the energy needs of Ukraine, because there will certainly be different needs in the Ukrainian context, it still gives a good indication of actually how much that these technologies can help and kind of an indication of the size. And what we found in our study is three main benefits. That these technologies could increase the overall system capacity achievable by 20 to 40%. So that's quite significant increase. They could also, when deployed together with conventional technologies, accelerate grid expansion by 5 to 8 years at TSO level and 4 to 7 years at DSO level. And finally, deploying these technologies could reduce conventional expansion costs by 35%, which could add up to 700 billion euros by 2040. So these technologies are commercially available and already being deployed all over the world. Of course, Current believes that this could and should be scaled up much faster in general. But I think nowhere is speed and energy independence more important than in Ukraine. So really important to use what we have and so that we can do more with less. And I would very much like to leave it there. I'm happy to answer any questions and hand over to also our experts presenting these technologies and how they can contribute. Thanks.
Thanks a lot, Layla, for this overview, and congratulations also on the study with Compass Lexicon, Fabien Roch. I think it's very timely, and as you said, time is of the essence. Means we see it just now, it's the COP in Azerbaijan. We are running behind. We will reach first time in 24 the 1.5 degrees increase, and therefore those technologies, they are all there, just need to be deployed. So the next one is myself. Let me briefly introduce the study that we did. And the thing is, when you work on Ukraine, you constantly need to adapt what you're working on. A country in war is not a normal Germany or France or something like that. And therefore, the purpose of this study that I started in May, June, was to find out how can we increase the exchanges, the exports, but also, let's say, in the future, imports between Ukraine and between the neighboring countries. And here, how to do this for support next winter. Here's an overview on the solution identified, and I'm very happy to see that the first recommendation that we issued in August, 1.7 gigawatt need to be increased. Yolanda mentioned this to 2.1 gigawatt. This starts from 1st of December, has been achieved. We only asked for 2 gigawatts, so I'm happy to see 2.1 gigawatt is now a reality. Also, N3 changes the methodology in calculating the flows through the regional coordination center TSC net from March onwards, which allows for a more dynamic adaptation to exports, imports. I will come back to this. And we clearly ask for a further increase to 2.5 gigawatt. Second part of the solution is use lines without adding them to the 2.1 gigawatts, because the issue is clearly when you have integrated power system like this regional group, Continental Europe is a huge integrated power system. The frequency stability might be at stake, especially when you import to the region. It's much less at stake when you export from the region, but this needs to be kept in mind constantly. Therefore, using lines that are so-called antenna lines that are not part of the, say, calculation integrated system, that are isolated, can help to export even more. And then we know from N3 that the 12 year is the normal time for building transmission grids. This is way too slow. And therefore, projects that are like sea snakes in the discussion since a while between Romania, Slovakia, and Ukraine need to be speeded up. And I hope that Yolanda and DGNR can really push this, and so we put it on the PCI list, that is Isacha line to Romania and the Kapushani line to Slovakia. They are the crucial elements of the future interaction between Ukraine and the neighbors. Use all available technologies, of course. Use the 110 kV lines. I will come back to this. This is very interesting, which is the first level of transmission across the world. Historically spoken, a little bit forgotten, seen as toys, can contribute quite a bit. And then finally, a governance framework for regional electricity integration. I briefly go through those elements. Please, next slide. The slide before, it just shows how N3 since 16 March 2022 increased the exports. The imports were settled then at 550 megawatt for the reason of the 50 hertz frequency stability. But the experts have reached now 2.1 gigawatt from 1st of December, which is fantastic news. And thanks also to the European Commission to push in this direction. Next slide, please. This slide shows, and here it's a map from 2018. I have the map from Ukrenergo, with who we work very closely, but I cannot share it because of, you can imagine, in martial law times, a lot of data are security sensitive, but this map does the job. It shows that Ukraine has many interconnections, of course, to the east, and this is currently like the Donbass and some occupied territories are connected to the Russian IPS-UPS system, and not anymore with mainland Ukraine. But when you look at the many interconnections to the west and the south, Poland, Slovakia, Hungary, Romania, and Moldova, this is a fantastic situation, much, much better than the Baltics that will synchronize on 8th of February 25, as we know, and that are only then connected through Litpolbat. So it's a much better situation, and this is an opportunity we should not miss. Next slide, please. So briefly talking about this line, Rzeszów-Chmielnicki, this was an exemption from the 12 years rule. Within only 1 year, Poland and Ukraine used again former 750 kV line, have repowered it to 400 kV and built it up. But, and people from Smart Wires know this very well, and we are working on that as Smart Wires as well, of course. There's a lot of impedance on that line, which means like the line cannot be used as it should to 750 megawatt. It's only used, or even more, to 400 megawatt. There needs to be innovative grid technologies, and I strongly encourage Smart Wires to reconnect with PSC and with Ukrenergo to offer the solutions. I heard fax devices mentioned in many conversations I participated in with both TSOs. So this should be done fast to use the potential of this line. Next slide, please. Yeah, so the dynamic line rating. Also, when I was in Kiev now in October, I discussed with the acting CEO of Ukrenergo, Mr. Brecht, who told me that dynamic line rating has already been assessed within Ukrenergo, and they are now going for a pilot. They surprised me in saying that they want to use it more in summer than in winter. So maybe someone from the DLR companies can explain why more in summer than in winter. This honestly didn't make sense to me as a political scientist. The capacity increase also on the cross-border 10 to 30%, according to the 3 companies from current I talk with. And I even heard that Operato and the government of Slovenia are happy to give it for free, but it's not yet happening. It should happen much faster. So there needs possibly to be a permission by N3. Sorry, there's a mistake in my slide here. It's a 1.7, it's 2.1. Current cap is true, but from December 2.1. So N3 needs to agree that these DLRs on the interconnectors would increase, of course, the capacity at some point in time. The TSC net calculation will possibly help. Next slide. And then this 110, and this is really interesting. It was mentioned to me first time in our working meeting with Ukrenergo, Mr. Kudrycki, who was the CEO in Ukrenergo until recently, and he was saying we should use those 110. It's too expensive for this horrible Putin to destroy the smaller devices. They are to be built much faster. There is a wealth of such lines, including cross-border to Moldova, but even there's a line between Slovakia and Ukraine that's currently operated at 35 kV that could be used very fast, and it's currently under investigation. The funny thing with the Slovakia question is that it's a DSO. So this is a DSO interconnection, and I think there's a need to look into this. Also commission that normally interconnections are only TSOs, but I think there needs to be some progress in the regulation to allow 410 kV cross-border lines that are short and connect, for example, 50 megawatt wind power plants with something on the other side of the border. And Moldova and Ukraine are also looking into this. I'm not talking now about these, say, technical challenges that can be discussed at some other points, but here I see really this Ukraine 110 kV case study could be relevant for the EU at large, not only for Ukraine. Next slide, please. And then last but not least, means we have seen this BMIP Katarina Sikov, and the DGNA, you have been doing a fantastic job together with parties to use BEMIP, Baltic Energy Market Integration Plan, to boost this integration of the Baltics to the EU. Something like this is missing. I was told by Commission that CESEC is possibly a right format, whatever it is, but CESEC doesn't have any working group so far for this. So there is a need to look into all these countries, Romania, Hungary, Slovakia, Poland, Connect, and Moldova, of course, yeah, and have a regional approach, including on PCIs and future projects that are needed. I stop here and thank you for your attention. And as a moderator now, I immediately hand over to the next speakers. We are now entering the representatives of the companies. So Alex Houghtaling is a leader in energy, in innovative technology in the energy firm since many years. He was in LineVision, he's in LineVision today, but was before in NLX, which is a leader in smart energy management and cloud technologies, and NOC, also energy intelligence software, and Abbott Laboratories global health technology leader. So very keen to have you, Alex, present us the solution by LineVision for Ukraine and beyond.
Great, thank you, Susanne. Dynamic line ratings, you've heard it mentioned a few times in this meeting already. Dynamic line ratings are a reliability tool. Dynamic line ratings are a resilience tool. The people who operate the electric grid need flexibility to be able to move power, and they need to have options for how they do that. And that's exactly what dynamic line ratings are. I'm going to be talking about the concept, really the what, around dynamic line ratings. And then I'll turn it over to Brian, who is going to talk about how, really how to implement this and how to get started. So when you think about a line rating, it's not dissimilar from how you might think about a motorway. The electric grid has a lot of similarities to a motorway. You can only handle so many cars on a road at a time. And a line rating is the limit, the upper limit for how many electrons, how much power you can move on the transmission system at a given time. And what goes into that rating is a group of assumptions around what's happening outside. So what are the things that affect the temperature of a conductor? And those outside conditions will set that upper limit, and it's governed by an equation that utility grid operators use to understand the temperature of their asset. Because ultimately, for thermally limited assets, transmission lines, there is what we call an MOT, or a maximum operating temperature, that can't be crossed. And we need to understand what that is, but in doing so, we have to use a set of assumptions because we don't know what's going on there on the grid at any given time. So those assumptions are really governing the amount of power that can be moved. Next slide. So why do we need these line ratings? Why do you have to have a limit for how much power you can move? Well, again, these are thermally limited assets. These are pieces of metal hanging out there between towers. And really, there are two things that will determine what that maximum temperature is. The first has to do with safety. So the hotter a piece of metal gets, the more those molecules expand and sag. And if they sag too much, you can violate a clearance limit where the line will sag to a point where it can interfere with vegetation. It can interfere with the crossing of motorways or rivers. You can't have that piece of metal sagging too far from a safety standpoint. And then there is a standpoint of damage to the asset itself. So if a line gets too hot, the molecular structure can change and it can anneal, and that results in permanently damaging the asset itself. So it's losing tensile strength, which will not allow it to move as much power. It'll also continue the sag. So really you have to be very careful about how you are loading this line so you don't exceed those limits. Next slide. So I mentioned that there are a set degree of assumptions that go into the calculation of a dynamic line rating. The most common really is the outside air temperature. So the temperature outside will have an impact on what the temperature of that conductor is. The amount of sunlight that the asset receives will also have an impact. But by far, the variable that has the greatest impact on the temperature of that conductor itself is wind. So much more so than outside air temperature, it's the presence of wind moving across a transmission line that has the potential to cool that line. And again, the cooler the line, the more power can be moved. And so you might think about, well, this doesn't sound all that complicated. If we understand the temperature, we should be able to understand how much power we can move. And that's exactly right. But the challenge is, and Brian will start touching on this and how this is actually deployed, transmission assets as a category are the least monitored, the least understood in real time of all assets that a utility might own. Because once a transmission line leaves a substation, virtually all transmission lines have no monitoring. And so that is exactly why operators have to use these assumptions to load their lines. And of course, they need to be very conservative, because if you don't understand what's happening out there in the real world, you have to always assume that it's the worst case scenario. You have to assume that it's very hot out. You have to assume that there's very little wind. And when you do that, you are necessarily setting a limit on how much power can be moved. And that limit, if it's too conservative, really prevents operators from having the full degree of flexibility that they could if they actually knew what was happening out there. If they actually knew how much power they could move, then they would have that flexibility. And that's exactly what dynamic line ratings do. Next slide. So the assumptions that go into it that have to be conservative, this is just a quick image of how variable these different components are. So air temperature varies widely. Obviously, solar irradiance varies every 24 hours. Wind is variable as well. So there are all these different things that are happening in real time out there on the grid. But if you're only assuming the worst case, you're having a very set static limit for how much power you can move. Next slide. So this is just an image of the things that go into the understanding of the actual temperature of the asset. And what companies like LineVision and Ampacimon do are trying to understand what are the real-time conditions for all of these variables. We're using the exact same equation that utility operators use today. It's just that instead of using those fixed assumptions that I've been talking about, we're inputting the actual outside variables as they are occurring in advance to be able to give operators that real-time control. I'll turn it over to Brian here in a moment, but the last point I'll say is really touching on what Susanne mentioned as well. This technology, this concept is available right now. This is not an academic exercise. Dynamic line ratings are being used all over the world today in operations, delivering more capacity to TSOs and DSOs. Now, to Layla's point, this is not deployed nearly as much as it could be or should be. This is very easy technology to deploy, very easy technology to utilize, and it's really incumbent upon all of us to understand how to deploy this so we can get the most power out of the grid and use it as effectively and efficiently as possible. And now I'll turn it over to Brian. Brian will talk about how we're actually deploying this around the world and how it works. Brian.
Thank you. Just keep the momentum up and running and dive straight in. So if we could just go ahead to the contents there. I'll just talk a little bit about the different types of dynamic line rating. There's sensor-based and non-sensor-based. And then I'll talk about some of the practicalities of installing this and showing how quickly this can be done, especially in crisis times like we see in Ukraine, and then we'll wrap up. So jumping straight into it, looking at this slide here, similar to what Alex was saying, we have different levels of line rating, and typically most utilities in the world are one or two, static line ratings or seasonal ratings. But we can jump into ambient adjusted ratings where we consider the ambient temperature, and we can get a gain based on that. Or we can go one step further and include the wind and get even more gains. And the gains that you see on ambient adjusted ratings are in the region of about 5 to 10% capacity gains. But the beauty of this is that it's very easy to deploy. I don't need sensors on the line. I can go pure software, okay, get weather provider data and get it into the system very, very quickly. On the dynamic line rating side of things, you need sensors to get an understanding of the wind. Wind is a bit more unpredictable and a bit more hard to get a handle of. But once you get that wind component, you can get values up to 50% extra capacity, sometimes even more than that. Sometimes, really, we've seen some cases of even an extra 100% capacity gain at certain times. So jumping to the next slide, I'll talk a little bit about the components and going quite quickly here. And I understand that this is a fairly technical thing, but just to kind of break it down into little building blocks so we can understand the speed at which these things can be deployed. Fundamentally, regardless of the vendor that you choose, you will need a few things to get DLR up and running. Fundamentally, you need a rating engine, so a rating calculation engine, which is a piece of software. And the inputs into that system are, first of all, real-time and forecasted weather data. This comes from multiple suppliers out there in the world, the weather company, Meteomatics, different weather providers out there. Fairly easy to switch that on and get that weather. You can, as I say, for dynamic line rating, where you use the wind, you can bring in sensors from the lines, and get additional capacity there. Those sensors typically measure the conductor temperature, sag, wind, etc., the local conditions around the line. Once you bring that into the rating calculation, this engine, this is the guy that's calculating this every few minutes, every 5 minutes, and we send this out into our platforms, and this is how we get benefit. So we attach it to our SCADA for real-time benefits. So using this in the control room every day instantly gives you a lot more access. But more importantly, day ahead. So understanding 2-3 days ahead so that I can schedule my generation and plan well for the future. This is where the real benefits lie. Over and above that, I can take analysis reports and just use that to educate my operations day in and day out. One more slide. So just to give you a feel of how fast this can be done, installing the rating calculation engine, at least in a cloud environment, can be done in a matter of days. Okay, not even weeks, days, that we can actually switch this on and start to access those gains of AAR, so 5 to 10% extra capacity. Connecting that into your SCADA and taking it into use, it's not easy, but in crisis times, you can do it. If you really focus on this, you can get this done in a matter of months. Connecting that to your planning and market systems, again, largely business process and getting data into the right systems, this can be done in a matter of months. Adding sensors, there's a lot of different ways of adding sensors. Some are non-contact. Many can be installed by drones. Most of them can be installed live line. So there are ways to do this very, very quickly. And this can be done in a matter of weeks or months if we plan accordingly. And then the things that take a bit longer for a typical utility, but can actually be done in crisis times like Ukraine, is improving business processes, improving the systems, the back-end systems, getting this to be utilized. When there's a need, this accelerates, and this can be done in a matter of months. What I would do is I'd get this into the system, I'd get it running, I'd get it adding value, and then I would then focus on improving the reliability of the system. So to make sure that it never fails, make sure that it's always robust, talk about on-premise systems versus cloud systems. But fundamentally, these are things that you can push a little bit down the line, and it will help you to speed up in the short term. Mm-hmm. Hopefully that gives you a taster of how quickly these things can be done and also the benefits. So the key thing to take away here is that it's a tried and trusted technology. It's quick to deploy. There are solutions out there, and exactly where we are in a time of need, we can get this done very quickly. I'll leave it there and give some time back to some other people.
Thanks a lot, and thanks a lot also for your great interaction as possibly competitors on the DLR market. I invite now Romain Coullette, who represents Epsilon Composite Sales Director. Bonjour. He's a very enthusiastic promoter of sustainable carbon filter reinforced solutions. My God, what is this? That enhance performance and deliver fast return on investments in energy, airspace, construction, and machineries. Romain, you have been recently to Ukraine, I know.
Yes, thank you. Bonjour, Susanne. Hello all. Yeah, indeed, I was in Kyiv in September to meet Ukrenergo and various Oblenergo. So here today, I will present advanced conductors as one of the key innovative grid technologies that can quickly boost the energy transfer from continental Europe to Ukraine, but which is also very well targeted for upgrade project within the country for the distribution network. Next slide, please. So you all know about SCSR, so the standard conductor, which is the aluminum conductor steel reinforced, but probably you have not heard yet about composite reinforced conductors such as HVCRC. So what is a composite advanced conductor? It's a combination of high strength carbon fiber, insulating glass fiber, and high temperature epoxy chemical system. By combining these three elements by the pultrusion process, it's possible to produce a composite core, which is the backbone of that new generation of high temperature, low sag conductor, what you can see on the right-hand side. Next slide, please. So the main benefit of this conductor is the ability to carry as much as twice the ampacity compared to a standard conductor by using the existing structures. How is it possible? Because the maximum operating temperature for those composite conductor is up to 180 degrees, so which is double the limitation of a steel reinforced conductor, which we know sag at a temperature higher than 90 degrees. So this is a clear benefit that make it possible to enter into reconductoring projects to double the ampacity of a line without getting through endless study of impact, without bothering about right-of-way issue, and as well by keeping the construction work lead time under control. It's possible by our experience to have from a project awarding up to the delivery and the first installation of the conductor onto the existing lines to have a global cycle of less than 1 year. Less than 1 year to double the ampacity of lines, that is clearly unbeatable. And this is the reason why it makes this technology make it very attractive for transmission utilities and as well for distribution utilities. And particularly in the case of Ukraine, we all understand the benefits that we could get by increasing the ampacity and in the interconnection in between the neighboring countries, such as Moldavia, Romania, what Susanne already talked about, and how we could speed up the process to cope with the high need for energy right now. Next slide, please. So there's a second benefit in the use of those advanced conductor with the composite core. Though they are more expensive than standard conductor with a steel core, they have a very short return on investment. How come? Thanks to the reduction in the line losses, electrical line losses during the operation. Because those conductors, and you have a few sketches on the left-hand side, this is a standard conductor with a steel core, and the one on the right-hand side have composite core with trapezoidal aluminum wire around them. So we can see that there is a higher aluminum content by about 30%, so which make it possible to reduce the line losses to the same extent. So instead of being quite generical, I would like to present you a real case study that we are working on right now in Ukraine. So it's about a river crossing project where it's about upgrading an existing line, 110 kilowatt line, single circuits. It's a SCSR 240-32. So it's very common conductor side in former Soviet area based on GOST standards. And we are right now together with an Oplenergo studying two options for to reconductor this line. So first one will use exactly the same weight and same diameter conductor. So it will be a Lisbon size. So this is the one in the middle. So with a 30% additional aluminum content. Second option that we are studying right as well is the conductor, which is lighter and smaller than the existing SCSR conductor, but yet having the same aluminum content. So that will be a Gdansk size conductor. So what we can see if we combine those benefits in either the higher aluminum content and also the ability to double the maximum operating temperature, we can see that the line losses can be reduced to an extent by 25%, considering the DC losses and AC losses with a mean ampacity, which is about 450 amps, which corresponds to 75% of the SCSR load. So turn into savings, what does it mean? It means that we do have a yearly saving of about 122,000 kilowatts per kilometer on one side with the Lisbon, and only 18,000 kilowatts per kilometer with the Gdansk size conductor. If we consider an average price per emission, price per kilowatt-hour base of 0.1 euro per kilowatt-hour, we can turn this saving into euros and calculating our return on investment, which is in average, let's say 1 year, 1.5 or up to 2 year max for this specific case, depending on the operation conditions. So what do we have there? We have a solution, advanced conductor with composite core, which has been rolled out all over the world for more than 20 years, which is field proven, which answers the need of both distribution and transmission network, which can be deployed in a very quick way without additional effort, because I need to mention as well that we are using exactly the same installation procedure as standard conductor, the same type of fittings to all those conductors onto the structures, and therefore we can quickly deploy this solution and double the capacity of the line. So this is of course a great interest, not only for the transmission operators such as Ukrainian Go or the distribution operators, but as well for project developers that could have an interest in, connecting wind farm or solar farm and getting the savings into the electrical losses. So this is what Epsilon Cable is working on right now with Ukrainian utilities. And what we really need right now to deploy this technology is to get a first pilot line, because there's no such line installed right now in Ukraine. We do have some in the neighboring countries, but not in Ukraine yet. And to give a clear demonstration of how easy it is to use and about the demonstration of the benefits. And then there's no doubt that it will be rolled out at the same path as it is going right now in Western Europe and Eastern Europe. This solution tends to become more and more mainstream. Thank you.
Merci beaucoup, Romain. So now we are coming to the last presentation on solutions. And here, Mark Norton, 34 years of experience in the power sector, especially transmission and distribution, many management roles. He's today the Vice President, European Business Development of Smart Wires. Mark, what can Smart Wires do for Ukraine and beyond?
Thank you, Susanne. Hopefully the next few slides I shall enlighten everyone on the call. So maybe can I have the next slide, please? So I'm going to try and address very quickly 3 questions. What is the technology that we have and what can it do? How quickly can it be deployed? And what do we need to make that happen? So starting with the first of those, what's the technology and what can we use it for? Well, our principal product is a modular power flow control device, the smart valve. It is a static synchronous series compensator, a fax device with power electronics. But essentially, the most important thing is the word I used at the start, modular. So it is a device that can be combined together like building blocks or Lego in order to provide the capability that you actually need. So it's very scalable and it's very flexible in that respect. And it can control the power flow through the network. So the 2 little images on the right-hand side in the middle of the slide show on the left a network with a red line that's overloaded due to the loss of an unexpected loss of a circuit at the bottom. You can see the little red eggs through it. But you can see there's lots of latent capacity in that network. The top one is overloaded, is over 100%, but the middle 2 are not. By putting devices on to either push or pull energy, we can rebalance that. So we can control the way the power flows through the network, which gives us an opportunity to do a wide range of applications. I listed some of the key ones of those at the top. So we can increase the transmission and interconnection capacity in a network by using that latent capacity that's there and directing the power towards it. And very similar, we've heard from our dynamic line rating and advanced conductor cousins that they're looking to increase the capacity and connection on a network too. They would also say they can reduce congestion costs and integrate renewable energy faster by creating that capacity. We can do that also, but we do it by controlling through the network. So we can control parts of the network and adjacent circuits and adjacent parts of the network that we're not installed on through the nature of the way that we control the power. We can also do that for lines and for transformers and even phase shifting transformers. We're looking to extend the range and the size of those devices. They're often the binding constraint that's stopping additional capacity going through. So we can work on all the different assets on the grid. And as another range of applications is not only are we looking at capacity, but in an increasingly higher level of renewables. And in a situation where you've got quite a lot of volatility on a network, at times having a loss of plant and equipment unexpected or for major outages. Perhaps what the network wasn't originally envisaged for, stability becomes a very, very large issue. And the margin between stable and unstable operation diminishes. the devices can be reused or can be installed in order to maintain that stability. So capacity across all the assets, stability as well. Another facet is oscillations. We're getting oscillations across the network. The devices inherently will dampen those, but we are in the final stages of bringing active damping of those oscillations through the units as well. And one of the other key areas that we can use, and I'll talk a little bit about the deployment of these, is for outage and emergency network management. So in situations where you've had an unexpected loss of one or more items of plant and equipment, or you're having to do works and you're having to take parts of the network out, the devices can be installed very rapidly and control that situation for the duration of that period of time. So what does that mean in differentiation terms? Well, it means that the devices are incredibly scalable and redeployable. We have delivered in under 18 months, gigawatts of additional capacity, and we can continue to do that annually. One of our first deployments in the UK, we put in 5 devices working in tandem over an 18-month period. 1.5 gigawatts was released. In actual fact, an unexpected permanent closure of a generator occurred while we were doing that. And we were asked to see if we could get another 500 megawatts, which we were able to do in mid-construction by resizing 2 of those deployments. That's how quick and fast it can happen. The devices are stackable and therefore have quite a wide range of ways of being combined to reduce the cost and the footprint, and it lowers the cost as well. And they don't have a single point of failure. Each of the devices is independent of the other and will fail safe to a bypass condition, keeping the integrity line, keeping the integrity of the network if there are any issues. And I did promise I'd talk about deployment. It's incredibly fast to deploy, 12 to 18 months already mentioned. And how can we do that? Well, the slide here sort of goes over a number of the reasons why that's possible. I've mentioned it's modular construction, but the support structures on which the devices sit, and they are voltage agnostic. The same device is used at every single voltage distribution or transmission. So it's the same unit, repetitive, easy to install, simple in its design. It needs a concrete base at the bottom, a simple support structure like most items of plant and equipment in a substation. We can single and double stack, so yet again we can get that space down. We don't need to go for extra land. The devices themselves draw all the energy they need from the line. So the only thing it has is a single fiber connection which couples the units together in order for them to be controlled, and virtually all of the equipment can be recovered. So I mentioned it can be redeployed. Not only can you redeploy it, but you get 95% of the equipment you've installed back that you can reuse elsewhere. So in a situation where it's volatile and changing, you can move the devices and scale them very rapidly to accommodate. We've already looked at projects in the Ukraine, sorry. And we've looked at situations and where we could install and how we'd go about doing that. And we can see that this is very doable in the Ukraine as it would anywhere else within a year. And if you need a faster deployment, we can do that with mobile construction, which will do that in, or can be installed in under a day. So finally, what do we need to facilitate deployment? Very little, in actual fact, not much. If you wanted to get the installation in place in the next year, we'd need to engage with the customer, Ukraine most likely, in order to work out where the needs are and to identify what needs to be included in the tender. And we're looking for functional specifications there. We'd need a little help with the design resources and obviously any permits that are required, and the financial structure to keep the project positive in cash terms, which is a real issue for most of the innovation companies that are talking today. And then once we get to the construction phase, we'd look to use either the experience of the customer or a suitable EPC contractor, somebody to support us who knows the local standards, the local knowledge, the local way of doing things, who have the tools and the materials for construction available for us to use. And then finally, moving into an operational phase, we'd look to retain either the customer or EPC in order to continue to maintain and keep the equipment in the high level of reliability that it provides. It's about as difficult as that. And at that, I'll stop and open it up because I'm sure there'll be questions and answers.
Thanks a lot, Mark. And I think you all have been very disciplined. We have 16 minutes left for discussions. I would really like to invite now Yolanda. Yolanda, you have listened to all these technologies, proposals that could work in Ukraine, provided a brief overview on the current challenges. Maybe just to briefly summarize the current situation once more in terms of, say, a gigawatt that are possibly missing. The peak load next winter in Ukraine is expected to be 18 gigawatts. Depending on temperature, can be a bit more, a bit less. And the estimates of missing a capacity with no more destruction, which is also unlikely to be like this, is between 1 and 4 or even 6 gigawatts that will be missing in the Ukrainian system. Yeah, so there is a big need for all solutions, and the innovative grid technologies, of course, are one part of the solution here. So Yolanda, what do you think? How could one make sure that this is not just another webinar, but that solutions are implemented? What would be the way to engage between current membership on the one hand and Ukraine energy community on the other?
Thank you very much, Susanne. I think it's a very good question, because we need to put all this knowledge and technical elements in practice. So one thing is, like, of course, this is a very unfortunate, the invasion of Ukraine by Russia, but it's as well an opportunity. Whatever has been destroyed should be rebuilt, but not the same as in the past. Of course, some of the rebuild is just to survive before winter, so this is unavoidable. But when it's possible, we need to look beyond. We need to start using the best available technologies in order to rebuild and reconstruct the energy sector in Ukraine, and in particular look into decentralization. And you were asking me when I was talking about transmission, I want to talk about grids. Because part of the challenge is precisely not only to interconnect the country, that we have seen this is crucial, also to mesh the grid internally in Ukraine. And here there are plenty of opportunities in terms of decentralization, because the generation that is going to come is going to be more local, associated to renewable technologies. In particular, of course, we can mention photovoltaic, but other technologies as well. And we need to make the system smarter. And here we need to enabling with the technologies that we are talking about, that they are using the energy in a more efficient manner. I didn't mention in my presentation digitalization, but this is crucial as well. So we need to use the energy in the most efficient manner. It's like energy efficiency. We need to produce the energy, the same energy or more, with less resources. And I think this is an opportunity as well for the grid. So we need to put this in value. Now we are helping Ukraine in the deployment, in the implementation of the National Energy and Climate Plan. And it's a plan that is bringing investments. So we need to be sure that when we are implementing the targets included in the Ukraine National Energy Climate Plan, we put the best technology available and make the system flexible from the demand side, from the supply side. In order to do it, we have the crucial part, grids. So with this, with the knowledge that we have here, the companies that you have the expertise, what we need is to ensure that Ukraine is putting this technology online. What we are going to do from our side, we are in close contact inside the Commission with those departments that they are part as well in terms of financial terms. We have the Ukrainian plan, 50 billion. That is the biggest financial envelope for a country, for a third country. And this 50 billion is going to be materialized with concrete investments and reforms. So what we can do as well is to ensure that this money that is going to mobilize from the public, but also private investments, are going to go to this area that we think is crucial. So I will encourage you to that with us. So Susanne, you have put already us in contact to be sure that we can bring this expertise when we are implementing the plans, in order to be sure that the money is mobilized on one of the key areas in the energy sector, that is grids in Ukraine. So we are going to really be attentive about this. We know you. So now it would be to connect the dots. From one side, we have Ukraine. For another side, we have, of course, you, the companies. We can facilitate as well this discussion, and in particular, to use your knowledge to be sure that this is implemented in the plans, in the investments that we are partly finance, the European Union, another part will come from the private investors. Last but not least, we have the Energy Community Support Fund, Ukrainian Support Fund. Is more than 700 million that has been thanks to many donors across the member states. And this is as well an important money in order to repair the sector, but in order as well to modernize the sector. So I want to really encourage you to be in contact. And Susanne, maybe we can do it later on with another concrete webinar when we can bring deliverable results, what has been done in terms of concrete actions that have been implemented in Ukraine, thanks to put together the money, put together your technology, put it as well as Commission, as facilitator in close contact with Ukraine, and to facilitate the reforms that you think are crucial in order to mobilize the investments and in particular the innovation that the energy sector needs.
Thanks a lot, Yolanda, for this very important statement, also referring to National Energy and Climate Plan that's related. So inside, I know there's this so-called Ukraine Facility Plan, 50 billion that will be spent for the next years to support Ukraine's transition. And there's money available also in energy community. It's still not an easy country. Mark mentioned the EPC contractors who is happy to go to Ukraine these days and install devices. This is not an easy one, but there is knowledge there. And therefore also to you, Yolanda, I think this forum that we kind of need, this platform, something like CESEC working group, something like a BIMIP for this region is so crucial to bring the right parties to the table and discuss. I also saw in the chat there was an idea by Angelo to have a study on CBA on such technologies. I think that's also a great idea. So maybe some sort of internal brainstorming run through current, and me as well as Yolanda and everyone is happy to connect you with the decision makers, let's say, or the ones that move today, the things, energy community, Adam Zwetsch or others will be certainly a very good idea. But maybe from our 56-person audience, someone else wants to simply comment here or have a question to one of our speakers, or maybe the speakers also want to react to the other speakers. So please just raise your hand. And then I see, of course, the Baltic synchronization, my favorite topic. That's good. But this is a little bit another discussion. Harmony link will not be built, as we know. At least that's my understanding. Angelo, you're mentioning Baltic synchronization. 8th of February, there's a lot of panic in the Baltics because the war started when Ukraine went in island mode. But this Harmony link, to my understanding, will not be built, but there will be by 2030 another AC line parallel to Litpol-Balt near to Via Baltica. But I see Mark raising his hand. Mark, please.
Yeah, thanks, Susanne. And I suppose you asked, was there anything we wanted to comment on with regards to our colleagues' technologies and then some of the things that were said. One of the things perhaps that didn't get said, but would have liked to, but we had a short period of time, is the fact that there is definitely a very much a multiplying effect of applying more than one of these technologies together. And we've looked at that, and I direct you to the Compass Lexicon report on Current's website. That sort of shows some of the combined impact and then the size of that capability. It can and has been shown to reduce the development of networks by 6 to 7 years. So you can get a rapid increase in the capacity you're actually looking for. And we're doing similar work at the moment, looking at the distribution side of things and seeing the similar type of results. So we've talked quite independently, but I suppose if we'd had more time, we would have talked about the combinational effect. So I wholly support what Angelo has actually mentioned. I think that would be a very interesting outcome to see how much of the needs of Ukraine could be dealt by a combined effort. Thank you.
Thanks a lot, Mark. And again, don't see Ukraine only as a humanitarian case. It's really a very important country in the future geopolitics of Europe, with Poland being very central as well, and all the regions. So we just need to anticipate what this means for the EU and what is needed in terms of innovation. Other questions before I hand over to Andrzej for the concluding remarks? Any other questions? I don't see that. I just want, before Andrzej, you summarize, wrap up, and conclude, just want to again mention Yolanda's point. Let's see this not as a webinar that comes and it's over, but let's test our own ambition in having another conversation in 6 or 8 months' time. In the meantime, Current with its members, if it can be helpful, let's think together how these technologies can support Ukraine and Moldova, but also beyond, and what connections need to be made, and then we check what has been done. So that would be my homework for Current, but I hand back to you, Andrzej, for the summary and the conclusions.
Yeah, thank you very much, Susanne. And before maybe concluding remarks, I still wanted to refer to something what Yolanda said, which I think it's very relevant, but within the context, and here referring once again to the, let's say, European system planning process, while thinking about facilitating funds or investments or innovation, it's also, I think, important to take in mind the spread of available resources in the region, and also methodologies that are being currently developed that should facilitate all investments in the region. Because if it's done, let's say, in an encouraging way to put the investments into additional generation capacities in the region, maybe where demand is not needed nationally, those additional capacities could be used in order to support Ukraine. So it's not, I would say it's even making the view broader and to looking into the entire picture, because there is a huge potential in the entire region of Central and Eastern and Southeastern Europe as well. And maybe to conclude, first I would say that this webinar showing so many different perspectives is an evidence that such meetings are needed and that such conversations are important, because it's quite unusual and innovative to meet and discuss in such a setup, which already brings, I think, an added value with a commitment to follow up the discussion and continue in the future. And this already is very good deliverable, having such commitment. And I think that in order to support Ukraine also in a long-term perspective, such commitment is very important, especially looking at political developments taking place also globally, because it brings also some responsibility on us to act and to stick to these commitments. As let's say, at the end, we are all playing in the same team, and we need to have voices and expertise from many different actors. So I think that would be everything from my side. And I would, and of course, I would like to say thanks to all of you for a very interesting discussion. But I will give the floor back to you, Susanne, to close the webinar. Thank you.
Webinar is closed. It's only the beginning of conversation, and let's measure our words on the projects that we will develop together. I see great initiatives emerging in the chat already. Thanks a lot to everyone.
Thanks, Susanne.
Thank you very much, Susanne.
Bye-bye. Have a nice day.
Bye-bye.
Bye-bye.